Hi, this is R. Melanix, and this is my solve of my latest puzzle, Alien Wormholes. In this puzzle, you need to find 9 wormhole cells, one in each every row, column, and 3 by 3 box. Each wormhole cell has to have a different digit. So let's say this is a wormhole cell, and this has the digit 6. No other wormhole cells can have the digit 6 inside the cell. The value of the wormhole cell is is equal to the digit in the cell that's 180 degrees rotationally opposite in the grid. So this one is over here. So if this cell here is a wormhole cell, it would have the digit 6, but it would have the value of a 4 because 4 is 180 degrees rotationally opposite of the grid. In addition to every wormhole cell having a different digit, each wormhole cell also has a different value. So no other wormhole cell could have the value of 6 or the value of 4 here, or the digit of 6. So that's how wormhole cells work, and that's the key to this puzzle. The other rules are all relate to the values, which can be altered by the wormhole cells. And so along a palindrome, the values read the same forward and backwards. V clues, the cells joined by V sum to 5. German whispers, the green line. If two cells are joined by a green line, the values must differ by at least 5. These killer cages, the values sum to the total in the cage, and in these killer cages, values cannot repeat. And I think that's all the rules. Oh, and the region sum line, these orange cells, since they're along the blue region sum line, the sum of those cells is the same total as the sum of the values on these cells. So these are the values of sum. So those are all the rules. In the background, you might notice some little graphics, and they're just there to help with symmetry. So this is symmetrical to that cell. This cell is symmetrical to that cell, so on. So I'll quickly go through the solve here. The start is along the palindrome. That's the easiest starting location. And you can quickly realize that these two cells, because of the palindrome, must have the same value. So one of them must be the wormhole cell. And it will get the value from the cell that is opposite it. Let's make the wormhole cells purple. So none of these cells in green can be wormhole cells anymore. And now the next thing is to look at the palindrome in relationship to the V clues. So let's just put some placeholders here. So if this purple cell has a value of A, then you know that this cell also has a value A because of the palindrome. And this one, let's label it B, it has to be here because of the palindrome. So we know A plus B equals 5. So this cell here must also have the value of A. And since the value of A is already used in a wormhole cell, we actually know that's the natural value of A. And now that can bounce back because of the palindrome and be placed here as A. And again, we know that's a natural A because A is already used in the palindrome. It is used already in the wormhole cell. So now we have A on another V clue. So this one also has to have the value of B. And now we have a contradiction here. So the only way to fix it, since this is a natural cell, this has to be the wormhole cell. And we found our second wormhole cell. So let's quickly greenify these. So now the question is, what could B be, or the value, which is over here? What could this be? Well, it's 1, 2, 3, 4 because it's all on the V. And the tricky part about these corners with the German whisper line is because typically this will break without a wormhole cell because you need a place to put a 4, 5, and 6 cell. 4, 5, and 6 digit. You can hide one of the 4, 5, and 6s here. So and you can hide the other 4, 5, or 6 on the wormhole cell, but the other one, either 4 or 6, must be placed somewhere. 4 or 6 must be placed somewhere around here. And if it's a 4, it has to be surrounded by 2 9s, and one of those would have to be the wormhole cell. So if this is a 4, this would have to be a 9, and that would have to be a 9. However, since the value B is 1, 2, 3, or 4 for the 5 clue, we know that this can't be a 9. So the only digit 4 or 6 that can stick around here is actually a 6. So 6 would have to be either here or here, surrounded by a 1 and the value 1. So that actually gives you the value of B. So B must be value 1 in order for this German whisper to work. So we know this is a value of 1, so A must be 4. And this is 1, and now we know the value on this wormhole cell is a 4. And since this is the 1, we can hide the 6 now on this green line. We can put the 6 now next to the 1. So it'd be here or here, and surrounded by a 1 on the other side. And since this one blocks here, we know that this is a 6, surrounded by 1 and the value 1. And this has to be 4 or 5, because we have to hide the other one of the 4, 5, or 6 at the wormhole cell. And since the 4 is there, this has to be the digit 5, and the 4 can be hidden in the middle. And now we can place the other two low digits, 7, 8, 9 here. 7 can't be between 2 and 3 because one of them has to be a 3, so this has to be 8 or 9. And now we can shift our focus all the way to this German whisper, and we realize that now we still have the problem of placing a 4, 5, or 6 in this box. We can hide one of the 4, 5, and 6s here, and the other one we can hide in the wormhole cell, and the other one we have to place on the green line. So first, let's think about the 5. 5 can only be in the middle or hidden inside the wormhole cell. But since we already use a 5 in a wormhole cell, we can't put it in the wormhole cell anymore. So the only place in box 1 for 5 is the middle, since this is already used. So that's the natural cell. Now we have to figure out the 4. We know this is a low value, so these are all low. 2, 3, 4. And these all have the high values, 6, 7, 8, or 9. So the 6 is the actual digit that we're going to need to hide, because remember, we can't get another 1 value anymore. We can't get a wormhole cell to potentially put a wormhole here that has a value of 1 and hide 6 here. And the reason that can't work is we already used this wormhole cell already has a value of 1, and the rule states you can't repeat values in wormhole cells. So up here, we actually have to repeat the value 9 and hide the 4. So the 4 has to be in one of these 2 cells with the 9 surrounding whatever the 4 is over here. And the 6 is going to be the actual wormhole cell. So we can hide the 6 away in the wormhole cell. So the wormhole cell will get the value of 9, so it has to get the value 9 from the rotational cells. So it has to get the value of 9 from one of these cells in orange here. Since that one isn't a 9, one of these two must be a 9, which means one of these two must be the wormhole cell. I'm not sure which one yet. And we know the wormhole cell is a 6. This cell can't be a 6. Okay, now let's go back to the palindrome because I forgot one thing here. We know that the end of the palindrome has a value of 1, so this must be the value of 1. And it has to be natural because we already used the value of 1 in a wormhole cell, so that's a natural. Okay, and the next part of the puzzle is to focus on this region sum line here with these cages that are overlapping the region sum line somewhat. And then you focus on these two cells here, and you can actually do some math and figure out which these red cells sum to. There's a few ways to think about it, but the easiest way or the clearest way is to actually just do a little bit of simple algebra. So I'm just going to pull this up it's a super easiest way to do it. Some people can see this in their head. But let's take this 20 here. Let's focus on the box 7 right now. So box 7 says that, let's label these up. Make this A and this B. Box 7 says that A plus blue line is equal to 20. That's basically what it says. All right. And box 4 says that blue line is equal to B plus 16. See how that 16 plus B is equal to blue. So now let's sub B plus 16 up for this blue line, and we get A plus B plus 16 is equal to 20. So now I can quickly see A plus B is equal to 4. So now we know that these two sum to 4, and the only way to do that is to do a 1 and 3 or a 2 and 2, and because of these ones are looking at this, 1 and 3 is not possible, because remember, you can't get the value 1 from a wormhole cell anymore, because we already used that value here. So this has to be a 2, 2. So this must be 2 plus the wormhole cell that has a value of 2. And don't forget that has a value 2, so it has to get the value up here from this digit. And we'll deal with this very soon. But first, let's do some cleanup with the wormhole cells. This isn't a wormhole cell anymore. It's not a 6. You know, 6 is the actual wormhole cell here. And 4 is between the wormhole 6 and the 9. Making this 3. Because of the German whisper rules, that'd be 8, then 7, then 2. So now let's look at this cage here, and you can see that 2 plus a natural cell is equal to 14. Well, only way you can do that actually breaks. So this 2 actually has to be a wormhole cell also. So this wormhole cell has the digit 2, but looks at its value from this digit here. So these 2 digits that are highlighted now must sum to 14, this plus the wormhole cell. So these can be potentially 5, 9, or 6, 8. And it can't be 7, 7 because that would require two sevens in the cage, two value sevens, and killer cages cannot repeat values in this puzzle. So it's either 5, 9, or 6, 8. This can't be a 9. So this can't be a 5. Now remember, this has the digits for this value, but it's also a wormhole cell for the 2. But we already used a 5 in a wormhole cell, so it can't be a 5. And we already used a 6 in a wormhole cell. So this must be the digit 8. So 8 plus 6 is 14. So now we can see that these two digits, because the 16 cage, must sum to 16 minus 5, 11. So it could be 2, 9. It can't be 8, 3 or 7, 4 or 5, 6. So it must be 2, 9. So 2, 9. Let's look at this digit here, which is the same as this digit because of the palindrome. It can't be 1, 2. It can be 3, but it can't be 4, 5, 6, 7, 8, or 9. So that's placed. These are 5, 6, 7, a little Sudoku. These are 3, 4, 7. These two threes, or in fact, this 2 makes this a 3 in the corner. 3, 2. This is the 7 because of the German whisper. In fact, we actually know that this cell here gets its 9 from here. So this has to be the 9. 9, 8. So 7, 4 looks here, so that's the 3. These are natural. And now this is a 5, 6, 8, 9. No 5, 6. No 9 here. No 8 here. This is has to be one of these has to be the wormhole cell, which looks up at these two. I'll just highlight this blue real quick. So let's fill in Sudoku for these cells. 1, 2, 3, 4, 5, 6, 8, 9. And let's clean up a bit. 8, 9, 6. And look at the possibilities for the values for the wormhole cell that's going to be down here. It's either 3, 6, 8, or 9. 3, 6, 8, or 9. So can it be the 9? And the answer is no, because we already used the value 9. Because this digit is the value for the wormhole cell. And we already used the 9 here. This wormhole cell has the value 9. So it can't be a 9. Can it have the value of 8? And the answer is no, because this wormhole cell uses 8. And can it have the value of 3? And this one's a little harder to see, but if it has a value of 3, then the value over here would be 3, and we would repeat a 3 in the cage. We can't repeat a 3, so it can't be a 3. So the only possible value for the wormhole cell is a 6. It has to be one of these two, and this can't be 6, so this is the value 6 for the wormhole cell. So the wormhole cell is actually known to be here now, because it's 180 degrees from that. And again, we can't repeat 5 or 6 in the wormhole cell, so this must be 9, 8, and now, again, this has a value of 6 in the cage, so this can't be another 6, so this must be a 5. And by math, this is a 4 to make up 2 plus 4 plus 3 plus 5 plus 6 equals 20. Let's do some cleanup. This is a 1, 6 pair. And let's remove this. Now let's turn the focus back to our original wormhole. We know it has a value of 4, but right now I think you can determine the digit. So it can't be by Sudoku, the digit can't be 1, 2, 3. It can't be 4 because 4 is the value. It can't be 5 is already used, 6 is already used, 7 is available, 8 is used, and 9 is used. So it must be the only thing available is 4 or 7. So now that's a 5. 7 by Sudoku, this is a 9 and an 8 because the 9 looks up there. This is, do some more Sudoku. This is 1, 2, 3, 4, 7, 9. So this is a 7. That's a 9. This is a natural cell. I haven't cleaned that up yet. So all the 8 looks here. 3, 9, 8. So what can be here is 1, 2, 3, 4, 5, 7, 9. So that's 5, 9, 7. 1, 2, 3, 4, 6, 8 here. And 2, 3, 5 here. That can't be a 3. What's up here? 1, 2, 3, 4, 5, 7. So that's a 4. This is 1, 2, 3. So that's the 2, the 1, 3. Since we already used 2 in a wormhole cell digit, that can't be the wormhole cell. And by Sudoku, these can't be the wormhole cell, so this must be the wormhole cell. Not sure if it's a 1 or 3 yet. So now let's take some stock in what's available in the wormhole cells for digits. We used 2 here. We used 5, 6. We also used 7. One of these is a wormhole 7, 8, and 9. So all we have left is a 1, 3, and 4 for wormhole cells. So one of them's here. One of them is going to be over here. And the other one here. So 1, 3, and 4. Now 3 can't be here because of Sudoku, and 3 can't be here. So the only place left for 3 is there, 3 and 1. Now we have to place a 1 and a 4. You can't place a 1 here, so the 1 must be somewhere down here, which is a wormhole cell. And over here, we have a 4 that is also a wormhole cell. And here's a cool part where if this is a 4, it breaks because a 4 would be the wormhole cell. It would be the wormhole cell. And now this would also, this one cannot be the wormhole cell, so it would have to have the value or the digit 4, and that would clash. So, in fact, this is the only spot for the 4, which removes this, which makes this the wormhole 1, and makes this the wormhole 7, and this is the value 4. So we found all the wormhole cells. So now it's this mainly Sudoku left. So 5, 7, 6. That get resolved? Nope. This is 1, 2, 8. That's the 1. This is the 1 resolves here. 6, 1, 1, 2, 3, 4, 8. And 2, 3, 5, 6. What am I missing? Missing something easy, I bet. 5, 7, 3, 9. There's the 9. how 4 looks here. 8, 4, 6, 8. There's 6 here. 5, 6. This is the last digit place for 7 in that row, which resolves 5, 7, 6. This 8 looks here. 2, 8, 5, sorry, 5, 5, 6, 6, and now we're down to a little deadly combination here. And the only way to resolve this is to look at this cell and what the value of this wormhole cell is. It's going to be either the 3 or the 5. And if you look at this wormhole cell, it already has a digit 3, but it also uses or has the value of 3. So it has the wormhole cell with a digit 3 and value 3, so this one can't have the value 3, so this has to be 5, and that's how you resolve the puzzle at the end. That's Alien Wormholes. I hope you enjoyed it. Thanks for watching.